Hello, my name is Mustafa. Welcome to Lab 101. We'll be covering correlations with this video. We already done three statistical analysis, chi-squared, t-test, and ANOVA. This is the fourth one. Before starting, I want to talk about correlation versus causation. There's a huge difference in between the two, but if you use them incorrectly, you'll make a mistake. And if you're assessed, like internal assessment, during those parts, it will cause huge problems for you. So let's see the difference between the two. Let's start with this example. So the sun correlation is when something increases or decreases, the other thing is related to this one. So if this is increases, this is increases, or this is decreases, this might increase as well. The correlation is two-tailed, so it can go up or down. It doesn't matter, but the change in this will cause a change in this. Don't cause, but you'll understand. So the sun causes the ice cream buying in a society to increase. Also, the sun causes the sunburn increase. Both of these are correlated. Since this increases, this also increases. But this, like the ice cream buying, doesn't cause sunburn. The sun does. So you cannot say after finding a correlation that this ice cream buying causes sunburn. So don't use the word causation if you don't know, if you're not sure, uh, and you're not doing a math IA on correlation causation. You'll need a lot of sources to say that this causes that. You'll most likely going to say this is correlated when there's an increase in this or a decrease in this, there's an increase in this or decrease in this. Okay, so since we know what a correlation is, let's continue with our variables. One independent, one dependent. Both are numerical. These two both are numerical, and independent always in x-axis. You'll need to put the independent variable, your numerical independent variable, in x-axis. So let's see some examples. Change of pressure when volume increases. So when volume increases, pressure decreases. Both are numerical variables. This is the independent variable, and this is the dependent variable. Let's see hours heated and yield produced. So when you increase the hours heated, you'll get your yield increasing as well. These two are correlated as well. You can do a correlation analysis between the two because there's a numerical variable and there's another numerical variable, and when you increase this, you'll increase this one as well. Assumption for regression and Pearson correlation. So the statistical test we're going to do is Pearson correlation. Let's see our assumptions. Should be measured with interval or ratio. Okay, so let me give you some examples of interval and ratio. An interval is like a temperature probe. You'll get degrees Celsius or Fahrenheit, and with ratio, so there is an equal amount of difference between each unit of the Celsius, right? This is called in the interval, the difference between the units. So it should be measured with intervals or ratio. So what's a ratio? If you have an happiness index, if you ask people how happy they are between 0 and 10, you'll get a ratio. So a ratio is between 1 and 0. So it can be 0 to 100, 0 to 10. It can change, but it's a ratio. If you can if it's a ratio, you can use it as use it in the Pearson correlation analysis. Have to be numerical variables. You'll have to have your data set paired. So if you have it for each x value, you'll have to have one y value. It should be linear. If it's not linear, if you draw the graph of if it's not linear, then you have to you cannot do correlation. You cannot do even Spearman correlation because this requires to be linear as well. No outliers. If you have outliers, you can do Spearman correlation. Normality, the y-axis, only the y values should be normally distributed, And let's see our example. So we have an example, marks gained out of 100. I wanted to give a simple example rather than a natural science example. You already know, like, if you increase volume, you'll decrease pressure. If you increase yield, if you increase hours heated, you'll increase yield. So I'll give an extraordinary example. So our studied each week is x-axis because it's independent, and this is y-axis because this is the dependent variable. This the change in this will cause this. So this is the dependent, this is the independent. So this will be put in x, put in y. Let's see the assumptions for correlation. Should be measured with interval or ratio. This is a ratio since it is between 0 and 100. Uh, Pair data set, each x value has its y value. Yeah, we have those. Linear nature. So let's measure linear nature. As you can see, the data is not like plotted with an increasing order. What should I do? I come to the data should be like increasing, like 5, then 10, but I'm not going to change it one by one by hand. There's an easier way. I come to insert, no, not insert, data, sort A to Z, expand selection, sort, bam. Now your data is according to x-axis. You should do the sorting. Now let's see pair data set x value, yeah, linear nature. Let's draw it. I'll do regression, insert, charts, regression, scatter. If is it linear? Yes, it is linear. If I make a trend line, it goes linear. Yes, so we have a linear nature. Let me delete this one. No outliers. Let's calculate outliers for y. We don't calculate outliers for x. We're just calculating for y. Let's come to descriptive statistics. And let's see. Percentile calculator. Select my preferred data. Select my data. My data here. Delete spaces. Calculate percentiles. Q1 is 52.5. Q3 is 96.5. The interquartile range is calculated via subtracting Q3 from Q1, and you get the minimum value by subtracting interquartile range multiplied by 1.5 from no, wait, okay, I'll need to have this one here, from Q1, and I'll add Q3 to interquartile range multiplied by 1.5. 1.5. Yes. So this is the top value, this is the bottom value. These are both outside of our range, so I'm not going to even focus on these. So we have no outliers and normality. Let's see if we have normality, calculators, and calculators from here. Kolmogorov test of normality. I take the y values. I calculate the p value is so our alpha value is 0.05. Since our p-value is larger than 0.05, we accept the null hypothesis, so it's normally distributed. Our data is normally distributed, so we can do Pearson correlation. I come to calculators. I write Pearson correlation. If you want, if you don't meet the requirements or assumptions, you can do Spearman correlation. But we're doing Pearson correlation since we meet the requirements. I take my calculator here. I put the x values into here and y values into here. We're going to calculate r. The r, I take my r squared value here. This is the r squared here. R squared equals And let's come to calculate the p-value for this. And I take this value, r score, and let's see how many here. I check here. Let's see how many values do I have. I have 8. As you can see, I have 8. So I put for n number of each measurement. I put 8, 0.05, calculate. We have a p-value of 0.000017. Correlation hypothesis. Our p-value is really small, so we reject null hypothesis because our alpha is 0.05. If our p-value is smaller than 0.05, we reject null hypothesis and accept H1 alternative hypothesis. There is statistically significant correlation between x and y. Let's see. We have a correlation between x and y. And now we are going to use our r squared value that we found. So if the r squared value is between 1 to 0.75, we say that we have a strong correlation. And we slowly say that if it's between 0.75 to 0.5, we just say that we have correlation, we have weak correlation, we have very weak correlation to no correlation. 0 means no correlation. And between 0 to minus 0.75, very weak negative correlation, negative correlation, and between these values we say strong negative correlation. So when we see our r squared value, it is between 1 and 0.75, so we say strong positive correlation. Now let's draw the graph of these. I come to regression, no, not like this. I first select my data, then I come to regression, scatter plot. I have my scatter plot here. Most probably you're going to have multiple y. If you're going, like for natural sciences, you're going to have multiple y. Then you can put, like, assume that you have like this. Let's remove this one. Y, let's say just y. And y1. Your trial 2 and your trial 3. Trial 3. Let's choose similar numbers. 52. And like this. So, and you will have numbers here as well. I'll just put them here. You're going to have your means here. I take the average of these so that I can graph them. No, not like this, sorry. Like this, so that I can graph them. And then I take the standard deviation for samples. Don't do population, do samples. And I take my x values. They're the same. I take my x values. So I select these to draw my regression, like this. This is the exact same thing. Assume if you have multiple trials, you'll have to do it like this. And by doing this, you'll also be able to put error bars for each point. So let me come to specify value. Positive is this. Negative is this. I'll take the standard deviation values, and then I want to remove. I want to remove these ones. Yeah, I removed those by pressing the delete button. And this is it. I put the error bars here. I'll remove the chart title. you won't generally use it. You'll label this as figure one, like this, probably your figure one, and you will do you will add the trend line for it. If the plus sign isn't shown, I shake the graph a little bit. It comes. I press the plus button and I come to trend line. This should be linear anyways. I come to more options. I won't change anything from here. I'm just going to add the equation for it if I can. If I can. Equation on chart, yes. And then I show the equation here. Let's make it visible. We have the equation here. We have our correlation values here. So we can make assumptions for it. If you want to like this, if you want to decide on what would happen if like in the 60 range, if you studied for 60 hours a week, what would happen? You would calculate it by putting 60 on x and finding the y value. This is also, you'll need to label the axis. So hours studied, hours studied. This is always x-axis, hours studied, and this is marks gained. Yes. You will want to change your maximum value for here. So I come to select data. Is it on select data? No. I come to here for axes. I come to more options. The maximum for this one. The maximum will be 100 since it's a ratio, and this is it. Your graph is ready. You can label like hour studies and uncertainty value, marks gained uncertainty value as well. This will be your graph. This is your R squared value. This is your P value. And you know that it's a strong correlation. And that is it. Thank you for listening to me.